Hello all. Today we will solving the equations using Gauss Jacobi and Gauss Seidel method. First, let us take an example of one equation where I will solve using the same three equation using Gauss Jacobi as well as Gauss Seidel method. First, let us see using Gauss Jacobi method. In the meanwhile, we'll see for the Gauss Seidel method. Now here, first, whenever the equations are given, first we have to check for the diagonal dominancy. Diagonal dominancy means here in this case, here you can see 8x1 plus 2x2 plus 3x3 equal to 30. Okay. Similarly, next equation x1 minus 9x2 plus 2x3 equal to 1 and 2x1 plus 3x2 plus 6x3 equal to 31. Looking at this equation, let us see the first equation. Here the coefficient of x1 is 8. So this 8 when compared to other two coefficients of x2 and x3, it is more. So here 8 will be leading the other two, and since it is the first equation and it is in the first position, so if I draw a diagonally like this, wait a minute, if I draw the check diagonal like this, then this will be the diagonal. Okay, so here for the second equation, the coefficient of x2 comes in the diagonal line. So here this 9 is greater than to the other two coefficient. Similarly, when you come to the last equation, the 6 will be larger when compared to the other two coefficient. So this is arranged in such a way that the diagonal elements are greater than other numbers. So if we arrange the equation in such a way that then whenever we try to do the iterations of any method, it will converge faster. It will converge faster. So we have to check it. And in this equation, it is already the diagonal dominance is there. Therefore, we will straightly go for solving the equation. Okay. Now, whether it is Gauss Jacobi or Gauss Seidel, the first method is always bringing from the first equation you are getting the x1, from the second equation you are getting x2, and from the third equation you are getting x3. Okay, so I'll write the equation. Let us name the equation. Let this be 1 and this equation 2, equation 3. Okay. Okay, now from equation 1 we can write x1 equal to 30 minus 2x2 minus 3x3 whole thing divided by 8. Okay, and this can be written as 30 by 8, it is 3.75. 2 by 8 is 1 by 4, it is 0.25 x2 minus 3 by 8, so it is minus 0.375 x3. Okay, so this is one equation. Similarly, equation 2, that means this equation, it will give, we have to find out x2 from there. Okay, so x2 equal to 1 minus x1, okay, minus 2x3 whole thing divided by, here it is minus 9x2. Now I am keeping x2 here and minus 9 goes to the other side, it becomes divided by minus 9. Okay, similarly equation 3, okay, equal to x3 equals equation 3, from this we'll find out this x3 equal to 31 minus 2x1 minus 3x2 divided by, what you will get, 31. So this is how the equations are solved. Okay, now this I will remove the denominator and I will write a simplified equation. So 30 by 8 already I have written here. So x1 equal to 3.75 minus 0.25 x2 minus 0.375 x3. Okay, similarly x2 equal to 1 my sorry okay x2 equal to minus 0.111 1 divided by 9. Here it is plus sorry minus. Okay, because 1 divided by minus 9, 1 divided by minus 9. Similarly here 0.11 x1, here it is minus, here it is minus, therefore this will become plus. Similarly plus 0.22 x3. Okay, and x3 equals this, x3 equals 31 by 31 sorry, I did some mistake. Yeah, here this is not 31, here it is 6. Okay, this is not 31, it is 6, because 31 minus 2x1 minus 3x2 divided by this 6 is there, right? So x3 equals 5.16. 30 by 6 is 5, 1 by 6 is 0.16 minus 0.33 x1, it is 1 by 3 minus zero point 0.5 x2. So now this is the equation what you are going to get. So let us name this equation as A, B and C. Okay, so we got the equation. Now let us name this equation. Let this be A, B, C. Okay, now we are going to do the iterations. So in the first iteration, iteration 1, we'll put x1 equal to 1, x2 equal to 1 and x3 equal to 1. So this is the first trial we are going to do. So now we are going to find out the values of x1, x2 and x3. So while we are finding the values of x1, in the place of x2 and x3 you are going to substitute these values. So x1 equal to 3.750 minus 0.250 x2 minus 0.375 x3. Okay, so here in the place of x2 and x3 you are going to find out you are going to put the values of x2 and x3 value. Okay, so here x2 is 1. Okay, x2 is 1, I'll substitute that, minus 0.375 x3, that is also 1. Similarly, x2 equal to minus 0.11 plus 0.11. Now here you are going to put the value of x1. x1 is how much? 1. I am going to substitute that. Plus 0.22 x3. What is the value of x3? It is 1. So I am going to substitute there. Similarly, x3 equal to 5.160 minus 0.33 into x1. x1 value is 1 minus zero point 0.5 into x2. x2 is also 1. Now you are going to get the value of x1 and x2 and x3. So this is in the first iteration you are going to get using Jacobi equation. Now if I put x1 x2 equal to x3 equal to 1, okay, now the x1 answer will be 3.125, x2 will be 0.22 and x3 will be 4.33. Okay, so this is the answer what I am going to get, and here x1 is 3.125 and x2 is 0.22 and x3 is 4.33. 4.33. So this is what you are going to get in the first iteration. Now we'll do the second iteration. So in second iteration, we are going to substitute the value what we got it in the first iteration, that is x1 equal to 3.125, x2 equal to 0.22 and x3 equal to 4.33. Wherever x2, x1, x2, x3 are there, you are going to substitute this value in the iteration 2. Okay, so in iteration 2, x1 equal to 3.750 minus 0.250 x2. Now in the first iteration x2 was 1. Now in this case x2 is updated from 1 to 0.222. Okay, and minus 0.375 into x3 is updated to 4.333. Okay, you are going to get the answer for x1. Similarly, x2 equal to minus 0.11 plus 0.11 into x1. Now the value of x1 is 3.125. Okay, 3.125 plus 0.22 into x3. x3 is 4.333. Okay, and x3 equal to 5.160 minus 0.33 x1. x1 is how much? 3.125. Okay, minus zero point 0.5 into x2. x2 is how much? 0.22. Okay, you are going to get the answer for x1 and x2, x3. We'll see how much answer we are going to get now for x1, x2, x3 in the. Now we are going to get these answers. x1 equal to 2.069, x2 equal to 1.199 and x3 equal to 4.015. In iteration 3, what you are going to do? In iteration 3, these x1, x2, x3 updated values are used for iteration 3. That means whatever the answer you got in iteration 2, that will be the values for x1, x2 and x3 in the right hand side. And you are going to get the new x1, x2, x3 value in the iteration. Okay, from iteration 2 we got these values. Now we are going to put these values in these equations, and you are going to get the new value of x1, x2 and x3, and it will be 1.945, 1.011 and 3.877. Now these values once again will be used in the iteration 4. Okay, now from iteration 3 we got these values. What you are supposed to do this value? You are going to put this x1, x2, x3 value in the equation ABC, and you are going to get the new values of x1, x2, x3. Next, these iteration 4 values what you are going to get, once again you are using in equation ABC, this equation, and you are going to get the updated values of x1, x2, x3, that is 2.003, 1.008, 4.002. If you take further decimal places, such that values will be there. Okay, now these iteration 5 values once again you are using in this equation, substituting these values here and updated values of x1, x2, 3. Now as you see from the iteration 1, you got iteration 1 values as 3.125, 0.22, 4.33 for x3. See, as you see, x1 from 3.125 it has come 2.069, x2 0.22 to 1.199 and x3 4.33 to 4.014 when it comes to the iteration 2. And when it comes to the iteration 3, x1 is 1.945 and x2 is 1.011 and x3 is 3.877. Further, when you go to the iteration 4, the difference between these two has reduced x1 value. Okay, so in the beginning from iteration 1 to 2 it was more, and from 2 to 3 it reduced lesser, and now it is further it is reduced. Small difference is there. Here it is fluctuating. So the value is coming one in one trial it is going lesser than 2, and in one more trial it is going about 2. Okay, but the difference is less. When it comes to the x2, it is coming nearer to 1, and here it is 0.967. That means it went below 1 and this value is above 1. Okay, and when it comes to x3, it is 3.877 here in iteration 3 and 4.013 here. So it is also moving in above and below 4. Now let us come for iteration 5. What happened? It is coming nearer to 2.003, that is nearer to 2, and here it is 1 and here it is 4.00. This value you are going to use in the iteration 6, and it is further. See here, the value of x1 is less than 2, here it was more than 2, and in this case it is going nearer to 1. Here it was 1.008, here it is 1.001, and in this case it is 4.002, and in this case 3.995. So the difference you see, it is reducing, okay, between the two iterations. Now these value you are updating in the place of x1 x2 3 in the equation EBC, and you are getting the new values of x1 x2. Now you see, it was 2.003 here, now it is 2.002, and 1.008 came to 1.001, and now it is 0.999, and x3 is 4, exactly 4. Now use this value in the iteration 8 and you are going to get the answer as 214. Now it is 214, and if you want to check, put it in one more iteration of 9, and once again the value will not change, it will be 214. That means you have got the answer. You have got the answer for x1 x2 x3. The difference between x1 x2 x3 is very less. If you take further decimal places, maybe 6 or 7 digit, it may not be same. Okay, but I have restricted here to the 3 decimal places, and for 3 decimal places I got the answer as 214. So the answer for this equation is 214. Remember, here I required 8 iterations to get the uh, exact answer, or the answer which is nearer to the exact. Okay, in this case exact answer is 214. If you want, you substitute here 8 2s are 16, 2 1s are 2, that is 16 plus 2 is 18, 3 4s are 12, 18 plus 12 is 30. So that means this satisfies this equation. That means these are the answers for this equation, the values of x1 x2 x3. So this is how we are going to solve using Gauss Jacobi method. And remember, how much iterations we required? 8 iterations to get the exact answer. Now let us go for the Gauss Seidel method. We will see how we are going to do it in the Gauss Seidel method. Okay, in Gauss Seidel method, as I said earlier, the equation you are going to develop is like Gauss Jacobi method only. But only the thing is, here it is little the answers you are going to get sooner. Okay, so what we are going to do in Gauss Seidel method? So here in iteration 1, let us take the same trial values what you have taken in the Gauss Jacobi method. So in the iteration 1, we have taken x1 equal to 1, x2 equal to 1, and x3 equal to 1. Okay, so here x1 equal to how much? That means x1 is this one, 3.750 minus 0.25. X2 is how much? 1, and x3 equal minus 0.375 into 1. You are going to get the value of x1, and x1 you are going to get as 3.125. Okay, because we already solved that equation here. So here also this is 1, this is 1, the same answer will get. Now you listen properly. What is x2 now? X2, you have the equation of x2 here. What is that? Minus 0.111 plus 0.11 x1. Okay, x1. Now if you are doing Gauss Jacobi method, you will substitute here x1 as 1, but I will not substitute here x1 as 1. Instead, I will put the new value of x1, that is 3.125, which you got just before this equation. So this x1 is updated to 3.125. So I am going to put the new value. Okay, minus, sorry, plus 0.22 x3. X3 is 1 only because that value is not updated, and you are going to get the value of x, and you are going to get the answer as 0.4583. Okay, so this is the value of x2. Now this x2 equal to 1 is updated with x2 equal to 0.4583. Now let us use equation C and we'll see what you are going to get for x3. So it is 5.160 minus 0.33. X1 is how much? 3 point. You have to use the new value. Okay, and minus zero point 0.5 into x2, and don't use the value of x2 equal to 1 in this equation because just before this the x2 value is updated. That's why just strike using one line, don't fully cross it because this value was used here. So just you should not get confused whether I should put x2 equal to 1, or whenever you get the new value just strike off in a single line the older value. So now in this case x2 equal to 0.4583. So I am going to substitute that. Okay, and you are going to get the value of x2, sorry, you are going to get the value of x3 as 3.8959. Okay, 3.8959. So this is what you are going to get, the value of x1, x2, x3. So now x3 is also updated, so I'll strike out of this. Now I got the entirely new set of values, that is x1 is 3.125, x2 is 0.4583, x3 is 3.8959 in iteration 1. So once this is, and just remember here, see here in each step the updated values I am going to use, whereas in Gauss Jacobi method I am using the updated value after completion of iteration 1. That means after finding x1, x2, x3, in the next iteration I am updating it. But here it is not like that. Here it is after each step it is updating by itself, or the new values of variables are used. So now this is what the answer we are got from the iteration 1. Okay, this answer. Now you are going to go for the iteration 2. Okay, now we'll find out from iteration 2 what is the value of x1. Okay, you have the equation, I written the equation here. So it is x1 equal to 3.750 minus 0.25 into, now x2 value is this. Okay, 0.4583 minus 0.375 x3. X3 is how much? 3.8959. Okay, you are going to get the value of x1. Okay, and that x1 you are going to get as 2.1745. 2.1745. Okay, 2.1745. So this is the answer for x1. Now when I get this x1 in Gauss Seidel method, automatically this value will be updated with the 2.174. So next whenever I am using x1, the value will be 2.1745. So now x2 equal to minus 0.11 plus 0.111 x1. So now remember x1 is 2.1745. Okay, plus 0.22 to x3. X3 is how much? 3.8959. Okay, and here I am going to get x2 as, here I am going to get the x2 as, I am going to get the answer as 0.9963. So here answer is 0.9963. Okay, this is what I am going to get the answer for x2. Now you are going to find out x3. So once you get x2 as 0.9963, this value will be updated with the 0.9963. This will not be used further. Okay, So x3 equals 5.160 minus 0.33 x1. X1 is how much? 2.1745 and minus zero point 0.5 x2 you have to use new value, that is 0.9963. Okay, so x2 will be 0.9963 and you are going to get x3 as 3.9437. Okay, 3.9437. So this is what you are going to get the answer from iteration 2 for x1, x2, x3. So this x3 is updated with this value. Okay, now for the iteration 3 I am going to use this updated values of x1, x2, x3. That is these values I am going to use. Okay, 3.9437 is the updated value. Okay, let me copy that for a reference and I'll put it here. So this is the new values of x1, x2, x3. Okay, this is from iteration 2. Okay, now in iteration 3 you are going to get new values for x1, x2, x3. Okay, so when I am going to find out x1, I am making use of these two values. I am going to use of these two values, that is x2 equal to 0.9963, x3 equal to 0.3947. Okay, and I am going to get the answer as 2.0220. Okay, x1 as 2. 2.0220. Okay, so you are going to get the value of x1. Now what happens? This x1 is replaced with the 2.0220 to find out x2 to 0, and you are going to get the value of x2 as 0.9899. Okay, in the equation I am using ABC, and this value of x2 from 0.9963 is updated with 0.9899, and this value you are going to use to find out x3. Okay, so here it is 0.9899 and you are going to get the answer for x3 as 3.977. Okay, equal to 3.9377. This is what you are going to get from the 9977. See here, if I look this in iteration 3, what you got in the Gauss Jacobi method, and here it is converging faster. These values are converging faster. Let us see what you are going to get the answer in iteration 4. Okay, so in iteration 4 what you are going to do? Iteration 4, this value is updated with this. The updated values are used to find out x1, x2, x3. So first let us find x1. So for x1 you are going to use these two answers as x2 and x3 and substitute in equation ABC. So, okay, so this will be updated with 3.9977 and you are going to get the new value for x1, that is 2.0034. 2.0034 as the new answer for x1. Okay, so this value here will be cancelled and updated with x1 equal to 2.0034. Now this x1 and x3 value will be used to find out new value of x2. Okay, and x2 you are going to get it as 0.9999. 0.9999. So this value is updated with 0.9999. You see that this went more nearer to 1. Okay, now I will change the value of x2 here. I'm using Excel to calculate this. I already written the formula for this x1, x2, x3. Okay, you can make use of a calculator, and the new value of x3 is 3.9989. 3.9989. Okay, so these are the new answers. Okay, new answers. So these iteration 4 answers you are going to use in next iteration, that is iteration 5. Okay, so iteration 5. Okay, so you got the new answers. New answers are these things. From this you got it from iteration 4. Okay, now this x2 and x3 values are used to find out x1. Okay, so here I am going to use 3.9989, and new value of x1 is got, and it is 2.004. Okay, 2.004. So here I'll change it to 2.004, and new value of x2 you got, and that is 0.9998. So what I'm going to do is 0.998 I'm going to substitute, and I got the answer for x3 as 4, and I'll substitute here 4 as the answer. So now you see here, when I substitute for x1 I got as 2.001. So that x1 I'll substitute here. Okay, and this as 1. I'll put it as 1. Okay, I got the answers. But in the meantime, I skipped to write the answers for iteration 5. So I'll write it. So this is what the answer you got in the iteration 5. Okay, so next in iteration 6 you are going to use this values of x2 and x3 to find out x1. X2 value will be 0.998 and x3 will be 4. Okay, so that I am going to put the value here, and you are going to get the x1 as 2.001. Okay, and this 2.001 I'll substitute in the equation 2 to get answer for x2, and I am going to get the answer for x2 as 1. Okay, and this updated value I'll use to find out the answer for x4, and I am going to get as x3 equal to 4. Okay, so in iteration 7 I am going to substitute this x3 equal to 4 and x2 equal to 1, and I'll get the answer for x1 as 2, x2 equal to 1, and x3 equal to 4. Okay, if you see the Gauss Jacobi and Gauss Seidel method, okay, the exact answer you got in the iteration 7, whereas here in the iteration 8 for the 4 decimal places. And if you would have taken the decimal places for 2, then your answer would have been got somewhere here only. Okay, so here it will be 2, here it will be 1, and here it will be 4. So since in each step you are using the updated values of x, this Gauss Seidel method is going to converge faster. Whereas in Gauss Jacobi method, you are updating the value after a complete iteration. Okay, whereas in Gauss Seidel method, after each step, you are making use of updated values of x. So this is how the problem is solved using Gauss Jacobi and Gauss Seidel method. Okay, so that's all for today's video. Thank you.